Alright, welcome back everybody. My name is Dustin. In the last video we started looking into runtime reflection using EnTT Meta, and I also mentioned to check out EnTT meets sol2 for a little bit more understanding, especially this file here, the metahelper.hpp file. A lot of the stuff in this repo helped me have a better understanding, and I highly recommend learning by looking at other people's code to see how it's done, and then experiment on your own to see what you can do with it, or what you can come up with. So for today, the goal is to start the implementation of the reflection in our engine and remove the hard-coded entities from the editor and recreate them in Lua. So that's the goal for today. We're going to need to recreate these meta helpers and then start the process of reflecting the components, the entity, and registry classes. So let's start that now. So we'll come up here, and inside of our ECS, we're just going to come up here and call it new file, and we're going to call it meta utilities. .h, and we'll just go namespace Scion core utils. So these are just going to be free functions, and the whole point of this is to be able to get the types back and forth from Lua to C++. So we need a way to register and determine the types that we are sending. So there's this one function, we'll just say no discard EnTT ID type, and we'll call it get ID type. And this takes in a sol table reference, and we're going to need to have EnTT. And we're also going to need sol, and we should put our logger in here as well. So include the logger, logger.h. And then we're going to need to have two template functions. Template, and its type name args. That means it's a variadic template, and we're going to want to go inline auto invoke meta function. So this is going to actually do the invoking of the meta function for us. So we go EnTT meta type meta. Then we say EnTT ID type func ID, and then args So the first thing we're going to want to do is check to see if it is a valid meta. And if it's not, we're going to want to send an error. And just Scion error. No EnTT meta type has been provided or is invalid. And we'll just do an assert here as well. Did I do an assert? Assert. No, I didn't create an assert. So we'll just put a regular assert. And we'll just say false. Copy this. So asserts are ignored in release. That's why I'm putting the error as well, so at least you still have the error. And then here we'll just return a EnTT meta any. I think we can do that. Yep. And if we're good, here we actually want to get the function that is passed in and check to see if it is reflected with EnTT. If it is successfully reflected, then we will want to try to invoke that function. If not, we just want to return another empty meta any. So here we go. If auto meta function is equal to meta.func, and we're sending in the func ID. And the func ID is just your EnTT ID type. So this is the lookup utility for meta functions. Okay. And then meta function. And if that's good, we want to return meta function dot invoke. And we don't want to send in any handle here. We just want to forward the arguments. forward and args. Cool. And if it makes it to here, we just want to return an EnTT Meta any. Because that's what the invoke returns. It returns a meta any. So this works out great if we're sending in a meta type. However, if we send in a type ID, we can have another function here. If we go back to EnTT meets sol2, so right here, if you're sending it in, you're going to want to do EnTT resolve the type, and that'll give us our meta type. So let's do that now. So we go template, type name, args, again, inline, auto, invoke, meta function, EnTT, ID type, and then we'll just say ID. We'll just say ID. Then we go EnTT, ID type again. And then this one is the func ID. Func ID, and then args. Cool. And then here we're just going to return the above function. So invoke meta function. However, we're going to be sending in the EnTT resolve. And then we're sending in the ID. Then we're also sending in the func ID. And we're sending in the argument. So std forward, args. Cool. So if we're sending in just the ID type, it will then send it to here and then in turn call this function. So let's actually now do this function here, get ID type, and we'll build this. Okay, so with get ID type, we're assuming that we're sending in a sol table component, and this component must have already been exposed or registered with Lua and EnTT. So let's put a check in there to see if the component table is sent in is a valid Lua table. So we go if not comp.valid. So here, we're going to want to say Scion error, failed to get the type ID, component has not been exposed to Lua. And then we can assert as well, actually just go comp valid. And then we just want to return -1 here for the ID type. Okay, for all components and types that were exposed into Lua, we must also create a function that holds the type that has been reflected to EnTT Meta. And we can do that by ensuring all components have a function for type ID. So we go const auto, and it'll be func is equal to component, and see if it has the function type ID. And we'll go over that when we get to reflecting the components. And this will just be a sol function. Okay. And then again, we want to ensure that the func is valid. Assert for now, func valid. And let's put a little message in here. If the func is not valid, we want to say type ID function has not been exposed to Lua. Please ensure all components and types have a type ID function. When creating the new user type. Cool. Now, you don't have to put this big message in here if you don't want to, but I found it helped me to remind me. And then here you just want to see if func is valid. Again, and then just check if it is valid. We want to go func.get EnTT ID type. Or return -1. Sorry, this should be func because it is a function. So we're getting this func as a sol function. They also have this determine type one, or deduce type, but we're not going to do that one right now. You can add this in if you like, but I'm trying to just do a minimal example this time just to get it working. We'll go back and clean up everything later on. Okay, now that we have our utility functions, we need to start to expose our components and the entity class and the registry to Lua and EnTT. However, after we do this, from here on out, all new components must be exposed to not only Lua, but also to Meta as well, because we're going to need to reflect those and be able to see those. First thing we're going to do is bind actually the entity. So let's go to entity.h. If you take a look at our entity class, we already have an add component and get component functions associated with our entity. And the entity also has a reference to the registry in which it belongs to. So I would like to bind these functions to Lua and EnTT. First, we need to create a few functions. So down here, actually right here, we'll put it right here. First thing we're going to do is do a static create Lua entity bind. And this is what we'll be using to bind the entity and the functions for adding in the components to Lua. So we'll go static void create Lua entity bind. And this will take in the sol state reference Lua. And it also take in the registry reference and registry. Okay. And we don't have sol here, so we need to add in, include sol. We can just make that. That'll go into entity.cpp. Great, cool. Let's go back into .h first. So we have a couple more other functions that we have to make. We'll also need a register meta component function. This function will be a template that will register the desired component with EnTT Meta. After that, we'll have to make some free template functions below for actually adding in the components. So let's go template, type name, T component. And this is going to be another static. We're going to say static void register meta component. Cool. And this should automatically go into our, yep, see, it goes right into our INL. That's where we want it. I'm actually going to put this at the bottom. Cool. All right, go back to .h. And now we need to have a few free function templates. So we're not going to be creating all these functions, the add component, get component. We're only going to do the add component today. I'll show you how to do that today, and then I'll leave that as an exercise for you and try to do that yourself. And then we'll go over it in the next video. But in this video, we want to make a minimal example so the video doesn't take too long. So the first thing we're going to want to do here is make another function, go template, and it's type name, T component. And we're going to say auto add component, and it's going to take in one of our entities, a reference entity, and it's going to take in the sol table as a component. We'll just say comp, and then we'll say, and then it has to take in a sol this state s. So the sol this state is a transparent state argument for the current Lua state that you're using. We do not actually have to send this in from the Lua side. It is automatically added and it does not increment the count. This allows us to make Lua or sol references. And let's make this as well. Oh, I didn't want to make it there. So we'll cut this and we'll go to our INL file. I think this will take me there. Yay. Cool. And let's go right above our register. And let's make this in here. All right, so we have our add component function. Whoops. And in this one, all we're going to want to do is basically get the component back from our entity. So component is equal to EnTT, because we're sending in an entity, add component, and that's T component. And the first thing we're going to do is check to see if the component that's going in is valid. If the component is valid, we want to actually add it as a T component. T component. And if it's not, just putting a default value or default component. Whatever the default values are for that component. Cool. And then this add component returns a reference for us to a component. So here we can just go return sol make reference. That takes in your state and std ref component. Awesome. So that's done there. So now let's go into our entity.cpp and actually create our binding here for our entity. So the first thing we're going to need up here is actually get that meta utilities or helpers if you copied it right over from the other one. And now that we have our helper functions, we can go using namespace EnTT literals, and we say Lua, because that's what we called our sol state. New user type, and it's the entity, and we're going to call it entity. So this is going to be the name that is in Lua. So that's our bound name for this particular type. And we're going to want to say sol call constructor, and we'll have sol factories. And then from here, we want to go and we want to take in a reference. We're doing a little lambda function here, and it'll take in the name, const std, string, reference, name, and const std, string, reference, group. Okay, so our first one is just going to return an entity, and we're taking in the registry here, and the name, and the group. So what that was, it will construct it for us and return it to the Lua user. Now it doesn't know that it's taken a registry in. It just gets the name and the group, and it gets the entity back. And then we have to add our add component function. So add component, and this will also be a lambda. It'll capture a reference. It's taking in an entity, reference, entity, and then const sol table, and that's be a reference component, and it's taking in this state. Now we have to tell it to return a sol object here. I've tried doing it without that, but it can't deduce it correctly. So the first thing we're going to do is check to see if the component that's being sent in is a valid component. So if not comp.valid. Now, this is not actually checking to see if it's a valid component. It's checking to see if it's a valid Lua or sol table. It doesn't know that it's a component or not. Not yet. Return sol Lua nil t. All right, and then now we want to actually try to invoke our meta function for add component. So here we're going to go const auto is equal to invoke meta function. Oh yes, it's because I put it under the Scion core utils, I believe. Yep. And we're going to say using namespace, and then we'll go back in here, meta function. Cool. Get rid of that. So what does this need first? So let's go back over here. So what we're going to be sending in is the component. So we want to get the ID type and send that in. And then we want to call the add component function. And that's the reflected function that we haven't reflected yet, but we will do that. Get ID type. I probably should have did that first. Takes in component. Here, then we go add component HS, and then we're sending in our entity and the component and the sol state. Cool. That's the add component function. And then after that, we just have to return. So what this will send us back, this sends us back a meta any. So we want to check to see if we actually have an anything. So component anything. And if so, we want to cast it to a sol reference. And if not, just Lua nil again. Sol Lua nil t. Sorry, an object of Lua nil. And there we go. So that's all we're going to do for this part of the entity for today. This should be enough to actually get us going. There's a lot more functions that we're going to need to add. Get component, the kill component, things like that to get rid of the entity. Okay, so actually let's go back to the entity.inl, and we forgot to actually do the register function. So let's do that right now. And for now it's quite simple because we only have the one function that we're doing, just the add component. So we went over this in the last video. We just want to go using namespace, sorry I'm off today, namespace EnTT literals. And then we want to say EnTT Meta, and that's T component. And we want to say type is equal to EnTT type hash T component value. And we want to have a template function, so template func. And this is taking in our free function above here, so add, whoops, component. Don't worry, I'll figure this out. And this is the reflected function, so add component. Okay, .h or -hs underscore. This is what is called over here in entity.cpp. Right here, that's this function. So it's going to try to invoke this function. And if the type that we put in here, so if the T component type hasn't been reflected, this won't work. The invoke meta function won't work because that type hadn't been reflected yet. So now that we have this, let's go and reflect a couple components. So we'll go into our components and start with the transform component. All right, so the only thing I want to do here is add sol, include sol.hpp. And we're going to want to get static void create Lua transform bind, and that's all it's going to take in is the sol state Lua for this one. Okay, and we'll create that now. Cool. And because this is going to be the only function over here, I'm not going to add anything to it. I'm not going to take this out and do all that namespace stuff that I usually do. So for now, we're just going to go include. We need entity. And we're going to create a new Lua user type. So Lua.new user type, and this is our transform component. Transform component. All right. And we're going to call it transform. Transform. That's what the type name will be in Lua. And this is where we add that type ID function that it needs in order for it to be reflected correctly. And here, EnTT type hash transform component, and that's just the value. Takes in that, and we want to use sol call constructor, and we're going to use sol factories again. Now you can do sol constructors and build them there, but we're going to do sol factories for now. And we can go here, and we can go GLM vec2 position. We won't be able to use this one because we don't have that bound to the Lua yet, but I want to do that in the future. I do have that done in the main development branch, but maybe you could try that on your own to try to bind GLM to Lua. But we'll do this one anyway, and we'll do return transform component, and we'll go dot position equals position, that's going in, position dot scale is equal to scale, and dot rotation is equal to rotation, rotation being sent in, and we'll return that like that. That's for this particular one. We can't use that one right now because we don't have this bound. Give it a shot, try to do it yourself. So we'll make another one, and this one will take in float x, float y, a scale x, which is also a float, scale x, float scale y, and then float rotation. And here we can do the same thing. We can just copy this. And instead of that, we can go position is equal to GLM vec2 xy. Same with scale. GLM vec2 scale x scale y. Cool. There's our two constructors for now, and that should be fine. And later on, we'll do the GLM bind. We still have a couple more things to do. So usually we can just bind the member variables. However, this is a vec2, so we can't just directly bind that right now until GLM is bound. I keep saying that. We're gonna have to do that. So for now, for our position, we're gonna wanna go position is now equal to the lambda function. And it's going to take in a transform component reference, and we'll just call that transform. And it's going to return std make tuple of the transform dot position dot x transform dot position dot y. Cool. And we're going to do basically the same thing for scale. So just copy that, change it to scale, takes in the transform. Sorry, this needs to have a comma. And then we need to just change this to scale. And scale. Cool. And then one more for rotation. For rotation, we can just send the member function, or the member variable, sorry. So transform component rotation, rotation. Cool. I need another comma here. And right now, we'll just do these simple things. So set pos, so for set position, and it will be transform component reference, and that's transform. And we need our two, so float x, float y. We won't need these later on, but we need them for now. And that'll just be transform dot position is equal to GLM vec2 x and y. Cool. And set scale as well. We'll do the same thing. Set scale, float x, float y, sure, and scale. Cool. That is good for now. All right, so that's our transform component. So let's go to the sprite component and do the exact same thing. Go to sprite component. We're only going to be doing these two components this time because the video is already getting too long, but we'll do this one. So down here, let's create another static create sprite Lua bind. Cool. And go sol state reference Lua. And it also needs to take in Scion core ECS registry, and that'll be a reference to the registry. Oh yeah, this needs to return a void. It has no idea what we're doing. This is the function void. Cool. Let's make that. Go back. And here, let's add in our sol. And then also add in our registry. Cool. Okay, so for the Sprite component, it's basically the same idea. We're gonna go Sprite new user type, or Lua new, sorry. We're gonna go Lua new user type Sprite component. Sprite component. And we'll call it Sprite. And remember, we have to do this type ID for each one to ensure that it's reflected. Type hash, Sprite component, and that's going to be the ID associated with this particular type. Value. And we want to do the same thing, sol call constructors, sol factory. Then this one, we want to go const std string reference, and that'll be the texture name, and then float width, the width of the sprite, the height of the sprite, then the start position, int start x, int start y, and then we also want to send in the layer. Now we can have send the color in and all that stuff, but we'll do that later on because we're also going to want to reflect or bind the color type as well. But we'll do that later. So return sprite component, and we're going to be making a new sprite component to return, and its width is equal to width. I believe this is how we declared them. Height is equal to height being sent in, and UVs right now we'll just have equal to a, so UVs is just going to be equal to a UVs default, and then our color is going to be equal to a color, and just white for now. And white is 255, 255, 255, 255. Cool. And then after that, start x is equal to, sorry, we gotta put a dot here. It's equal to start x. Start y is equal to start y. And layer is equal to layer. And then our texture name. Texture name is equal to texture name. Whew, there's a lot for that one. Oh, I didn't name that right. Sorry. Cool. Now that we have that. Now for the sprite, we're good. We can just actually send in all of our member variables. So we'll do that. So texture name, and that's just going to be the member variable. Sprite component texture name, and then I just copy a bunch of these, and then it'll be width, height, start x, start y, layer, and that's good for now for those. So let's name them layer, because I've done that before where I forgot to change the names. Start y, start x, height, and width. And we'll have one more for the generate UVs function, generate UVs. And this one we need another lambda function, but this one needs to capture a reference. It also has to take a sprite component reference for the sprite. And that reference that we're capturing is actually the registry. So we want to actually get the asset manager. So auto reference asset manager is equal to registry dot get context. And our context is a shared pointer. of the asset manager. Now I don't think we added that in, so let's go add that in up here. So we want to include our resources, wherever that is. I think it's, yeah, right there, resources, and we want to include the asset manager, and we might as well go name space using namespace Scion resources, not rendering, sorry, resources. Cool. Now we shouldn't have to check to see if the asset manager exists, because by the time it gets here, we should have already added that in the registry. That should all be done during initialization. You could put a check in if you like, but I think we'll be fine. And then we go auto reference texture is equal to the asset manager get texture. And we want to send in this Sprite texture name. Cool. And then this one we want to check if the texture ID dot get ID is equal to 0, because if it's equal to 0, it hasn't been set correctly. So if it's equal to 0, we'll just say Scion error, Scion error, and we need our logger, so we might as well put our logger in. All right, so we have the logger, Scion error, and we want to just say failed to generate UVs, texture does not exist or invalid. Cool. And then we just send in the Sprite texture name there, and we'll just return. We don't want to continue from there. And then all we're going to do now is call the sprite.generate UVs function and send in the width and height of the texture. Awesome. So yeah, there's a little bit more to this one, but it's the same idea, and all components are going to be done in a similar manner. Okay, so I think we're almost done. So now we actually have to bind these to the current Lua state and register the components with EnTT Meta. So let's go to the script system, and that's right here. Open these two up and create some functions. Down here we can say static void register Lua bindings. Now taking the sol state Lua, and it'll take in our registry, so Scion core ECS registry reference. Okay, let's build this. And let's make sure all our components are in here. So we got the script component. Let's have the transform. And the sprite. I think that's all we're going to need. The entity, cool. Yep, good, good. And let's come down here. And the first thing we can do is get the create Lua entity bind. Why doesn't it see entity? Probably because of the namespace. So let's go up here and add using name space Scion core ECS. Go back down. Cool. And this takes in the Lua state and the registry. And then we want to register our transform component. Create bind. This one only takes in Lua. And then sprite component. Create bind. This one takes in Lua and the registry. Cool. Now that will bind them with Lua. So these will bind our components with Lua. Now we have to register the components with EnTT Meta. So we'll go entity, register meta component, and we'll register the transform component and the sprite component. Awesome, we're so close. So now we want to go into the application and call this function. So let's go to our application. We're going pretty fast here, so hopefully this all works. And we'll call this. Okay. So where do we call our main script? Because we're going to want to do it before we call the main script. So right here. Because if we call this and we haven't registered anything and we have types in there that haven't been bound, we'll have an error. It won't know where these types are from. So we actually have to register it here. So we can go Scion core systems scripting system, and this is our register Lua bindings, and we send in our Lua state, and we want that, and we want our registry, MP registry. So they should be registered now. So now let's actually get rid of our hard-coded entity. Where did we make that? Right here. We created our entity. Let's get rid of all of this. Keep the sol state, get rid of the entity, good. I think that's good there. Get rid of that. Okay, so we got rid of our entity. We can get rid of this temp texture as well. The goal, we don't want any game related stuff in here. That all needs to be done in scripts. So that's all removed. And let's remove all this as well. We don't need the view. We're gonna let's recreate this whole thing in Lua now. Well, let's try to. Hopefully I did everything correctly. I believe now we can go to our main.lua. Where did we put that? We put that in the editor. Assets. Remember, this is all for testing still. So main.lua. Okay. So now that we're in main.lua, let's get rid of this. We don't want to print anymore. And so the first thing, we'll just make a global entity. We'll call it JADE-ite. And that's just equal to entity. And we'll send in test entity. And give it a group of groupie. Groupie, baby. All right. So if everything was bound correctly, this should work, creating an entity for us. So let's add a transform. So we can go local transform is equal to JADE-ite add component. And we're sending in a transform, not that transform, the transform table. And we'll put this at 100, 100, and scale of 10 and 10, and 0 for rotation. And then we can also add a sprite and do the same idea. So local sprite is equal to JADE-ite add component, and it's a sprite. And the texture is a castle, and the width is 16, 16. And our start, we're just going to do the I again, and the I was 8 or 0 and 28, and layer 0. That'll do. We also have to call the generate UVs function, and generate UVs. All right, so now we should have a sprite created in Lua that is at this position with this sprite. Let's see what happens. And we have some errors. Pages, there it is. All right. Yeah, right here. You guys probably already saw that. Is there any more errors, or is that just it? I think that is just it. All right. Build again. And there's another error right here. Oh. Trying to type too fast, trying to be slick, and I make mistakes. You guys, again, that's another thing you guys probably saw. Oh yeah, silly me. So don't try to go too quickly. Forgot to put that in there. Okay, that should work now. Because the add component is a template, so it needs to have that type. It needs to know what type it is. This should work now. And we got an error. What's our error? Invalid key. Which one? So right here, create sprite, asset manager. Really? My asset? That's funny. I said we didn't need the check, and we actually needed the check because it doesn't know what the asset manager is. So I probably create the asset manager after I did the register. So let's go to the application. lua.cpp and see where I actually create the asset manager. I'm creating it here. I didn't add it. Yeah, I did right here. I added it. But I added it after everything. So let's actually move all this here. Probably get rid of that temp camera as well. Well, actually, we'll leave it. Let's move all that to here and see if that does the job for us, or the trick. Awesome, there's our eye, and that eye is actually being drawn from Lua. Let's recreate that rotation that we did before, but do it in Lua's script. We removed everything here with the entity. It's not being created in our application anymore. That's all coming from our main.lua. So let's go back to main.lua, and we took our entity, we added the transform component, the sprite component, we generated the UVs, create some variables so we can do some rotation, and we'll change some scaling as well. So let's go local rotation is equal to 0.0. Then we'll go local xpos is equal to 0.0. Actually, let's have it at 10. Let's have it at 10.0. And scale, we'll have that equal to 1. And move right. We're basically redoing that code, that test code that we did before. True. And local value is going to be to 0. Okay. So now in our update function, we're going to want to check our rotation to see what it's at. So go if rotation is greater or equal to 360, then rotation is equal to 0, and now our move right. So if move right and xpos is less than 300, then xpos is equal to xpos plus 3, and value is equal to value plus 0.01, and then else if move right and xpos is greater or equal to 300, then move right is equal to false, because we want to send it back the other way. And so then if not move right and xpos is greater than 10, then xpos is equal to xpos minus 3, and value is equal to value minus 0.01. Else if not move right and xpos is less than or equal to 10, then let's get rid of this, it's kind of in the way. Move right is equal to true. This is basically everything we did before in the update function in the application. Now move to Lua's script. Then we can go local position x position y is equal to transform position. And this is a function. And remember, we're returning a tuple of floats. And then we can go pause x is equal to xpos, and then transform dot rotation. Now the reason why we can use a dot here, and because this is a function, you can use a dot here as well, but this is syntactic sugar for, so if we use the dot here, we'd have to send the transform in with it, but this will allow us just to use it like that. So rotation is equal to rotation. And then we want to go transform set pause, and that's pause X, pause Y. Then we want to check if move right, then rotation is equal to rotation plus 9, else, not else if, just else, and we can just copy that, minus 9. Let's go the other way, and then we can go scale is equal to math.sine of the value times 10. Now let's put some clamps on scale is greater than equal to 10. Then scale is equal to 10. Else if scale is less than or equal to 1, then scale is equal to 1. Kind of want to clamp it between those values. Same with value. So go if value is greater or equal to 1, then value is equal to 1. Else if value is less than or equal to 0, set value to 0. Is equal to 0. And now we just want to set our scale, so transform set scale, and we'll just send in scale. Cool, and that should work. Let's see what happens. Oh, we got some errors, you know what, and that's fine. So it's expecting then near value on line 63, and it is then. Perfect, try again. And we have some more errors, which is good. So we're sending bad data. Transform component needs float in set pause. Oh yeah, see? Stupid. Capital T. That should work now. All right. Awesome, there we go. So now we're binding everything to Lua and using EnTT Meta to actually add this entity and its components and control it from the Lua script. Okay, so that's it for this video. There's a little bit of not necessarily homework, but you should go around and try to add in the other functions in on your own for the entity. Try to add the get component, remove component, add all those in and make sure that you register them as well. Also, for fun, try to go to GLM and bind vec2, vec3, vec4, and mat4. If you can bind those to Lua, that would be great. If not, we'll go over that in a future video because we're going to need to do that later on. All right, thanks for watching. Please like and subscribe. And if you have any questions or any tips on how to make the videos better, please leave a comment below. Also, don't forget to check out this here, the EnTT meets sol2, if you want a better understanding. And yeah, I'll see you next time.